Hello, my name is Drew Hogan. I am a computer engineering student at Utah State University, and today I'm going to be talking about this household timer I have made using an STM32 microcontroller. Taking a closer look at our clock here, we have a hand for the seconds as well as the minutes. We have buttons to increment the seconds and then increment the minutes to a desired time to count down. We have a button to start the countdown, or when the hands are at the starting position, we can simply hit the start and it will count up like a stopwatch. And then we have the stop button, which does a couple different things, which we'll talk about. As well, we have our piezoelectric buzzer here to let us know when our timer has counted down. And I've moved these clock hands a little bit so we could see right here there's a hole where we have some Hall effect sensors. And on the back end of these clock hands, I've glued some of these small little magnets. And this middle pin here outputs 3.3 volts, except for when this magnet is close enough to the sensor right here, and it will output 0 volts. And we use that to preset the clock hands to the desired position. Now looking at the back side of our clock, we've got some hinges here and some magnets to hold this door shut, but we can open it up. We have our microcontroller, as I mentioned. These are 2-stepper motors that control the clock hands, our motor drivers, our 2 Hall effect sensors. As well, we have a breadboard here with a 2.2K ohm resistor in series with our buzzer. And in addition, the power source plugs in just like so. And we've got a little slit here for the cord. So taking a closer look at our clock here, there's 2 things we can do. We can first, if we want to just start counting forward, you push the start button and the timer will begin to count up. There's a tick every second. And then when you're ready to stop, you can press the stop button once and the timer will freeze. And if you push stop again, it'll reset. So looking at our main function, we start off by initializing our sysTick. Here we are passing in 4 million. I'm using a 4 megahertz clock. And in this sysTick initialization, it passes in the countdown of this -1 so that we can have 1 second between each of our ticks. As well, we're using a simple state machine. So state 1 is our reset, or state 0 is our reset, state 1 is our preset. State 2 and 4 are in our sysTick handler, which I'll show in a minute. Those are counting up and counting down. State 3 is when we're buzzing, and state 5 is when we pause the timer. So at the root of all our software, we have a drive seconds and drive minutes functions. So we are using half-stepping. We go through this array. We're using half-stepping so we can use as much accuracy as we can without having to deal with pulse width modulation. So there are 8 different steps here. So at the beginning of our drive minutes and drive second functions, we find our starting position right here, which is mod 8. And that way we are picking up exactly where we left off. This is a macro global variable here that we're always keeping track of how many steps we've taken. So based off of that, we begin at our starting position and we simply loop through however many steps, and we're keeping track of our second steps. If we're going counterclockwise, we'll pass on a false here. We'll do the opposite and we will decrement our second steps respectfully here. So the other option is if we want to set a timer to count down. So let's say we want to set a timer for 15 minutes and 5 seconds. These 2 buttons, this increments seconds, this increments minutes. You can either push one and increment 1 position at a time, or you can hold it down, in which it will increment 3 positions slowly, and then it will pick up speed. So let's hold this one down to set the minutes, like so. And then if we just want to click this 5 times, we'll get 5 seconds. Then when we're ready, we push the start, and it will begin to count down. Now let's say you don't want to wait for the timer to run out and you're done. You hit the stop button and it'll reset. When we're presetting a value to count down from, we enter this preset function. And as you have seen, the first 3 steps are slow while we are holding down the button. So if the button's pressed, then we increment a second, then we delay. We check if it's still pressed, we increment again. If it's still pressed, we increment again. And then we enter this small while loop with a much shorter delay. And we keep checking while this button is pressed. And we have the same logic here for the minutes. So here we're looking at our sysTick handler. This function is called every second, no matter what. It's called by the hardware of the sysTick counting down. And we check if we're in state 2, meaning we're counting down, we'll follow this logic. If we're in state 4, we'll follow this logic to count up. And if we're not, we'll just check and then we'll go right back to whatever we were doing. So as you can see, it's pretty simple. If there's 0 hours, but 0 minutes, but 1 second, then we just decrement our second and go to state 3, which is the buzz. 0 seconds, 0 minutes, but we still got some hours. Then we decrement second, minutes, and hours. And here we need to decrement our seconds and minutes. And then most common, we're just decrementing second. Now this clock does keep track of hours. While there's nowhere to view how many hours, unfortunately, are still in the countdown, you can run the preset on the minutes and just circle, and it will keep track of the hours. And here, counting up, we just increment our second as long as we haven't stopped. And that keeps track of moving the minute hand where appropriate. So if we let our timer run until it's out of time, it'll buzz using this buzzer here. If it was set for 5 minutes or more, it'll buzz 10 times. And if it was set for 5 minutes or less than 5 minutes, it'll buzz 3 times. So to show that, I'll set a 3-second timer. So a few cool features about this timer is, let's say we set a short timer and the buzzer goes off, you can stop the buzzer. You just hold the stop button and it'll stop early. Now in addition, when presetting seconds, if you go too far on accident or intentionally, it'll just increment a minute like so. And the same thing happens for minutes. While this clock does not have a physical component hardware to show the hours, it does keep track of the hours. So you could circle these minutes and it would add hours to your timer and it would count down accordingly. Now, let's look on the inside here. These motors can actually get pretty warm naturally when electricity is being sent to it. And right now, we're sending a pulse to each motor and it's just holding itself in place. Well, if I reset this and it goes to its starting position, you'll see that I clear these drivers so that we're not sending any electricity to the motors. That way it's not an unnecessary fire hazard.